Hello from the outer space. As you know, AI is transforming our lives, from personal interactions to professional workflows. For those of us in the IT world, AI presents both incredible opportunities and potential risks to our careers as software engineers, quality engineers, DevOps engineers, and technical program managers, like myself. While some companies like Salesforce have made headlines with dramatic statements about hiring freezes for software developers, the reality is hopefully more nuanced. That said, let's be honest. AI is becoming a powerful tool that is about to drastically change the nature of our jobs. Like asteroids did it to our planet millions years ago, AI is about to disrupt our IT world at full speed. But it doesn't mean that our jobs are about to disappear. Our jobs are about to be transformed. In fact, I anticipate that IT roles will shift towards higher-level thinking, problem-solving, and strategic planning. And so, the best we can do is to prepare to thriving in this new landscape by continuously upskilling. Hence, in 5 short minutes, let's upskill ourselves on machine learning. Machine learning is a branch of artificial intelligence where computers learn patterns from data to make predictions or decisions without being explicitly programmed. It's like teaching a machine to improve its performance by learning from experience. There are 3 main types of machine learning. First, supervised learning, where the model learns from labeled data, like teaching it to recognize cats by showing examples of cats and non-cats. Second, unsupervised learning, where the model explores in labeled data to find hidden patterns, such as grouping similar customer behaviors. Finally, reinforcement learning, where the model learns by trial and error, receiving rewards or penalties for its actions. Think of how AI learns to play games or control robots. But let's talk about these approaches. Supervised learning is about training models on labeled data to make predictions or decisions. Here's what you need to know. Supervised learning has 2 main categories: classification and regression. Classification predicts discrete categories. For example, classifying emails as spam or not spam, or categorizing code as buggy or clean. Regression predicts continuous values. Think of estimating project completion time or predicting server load. Common applications of supervised learning include predictive maintenance, code quality assessment, and automated bug detection. Now, let's talk about a few challenges to be aware of. Data quality is crucial. So, please, ensure your training data is diverse, representative, and correctly labeled. You also need to be aware of overfitting, where models perform well on training data but poorly on new, unseen data. Last, you must understand the trade-off between model complexity and interpretability. Unlike supervised learning, unsupervised learning works within labeled data, finding hidden patterns and structures without predefined outputs. Here's what you need to know. The 2 main types are clustering and dimensionality reduction. Clustering groups similar data points together. Think of segmenting users based on behavior, or grouping similar code snippets. Dimensionality reduction simplifies complex data while preserving important information. Key applications include anomaly detection in systems, user behavior analysis, and feature extraction from large datasets. Now, let's consider a few challenges to consider when working on an unsupervised learning project. Data pre-processing is crucial. Normalize your data and handle outliers appropriately. Interpretability can be challenging. Be prepared to explain your findings to non-technical stakeholders. Last, let's talk about reinforcement learning. It's about training agents to make sequences of decisions by interacting with an environment. Reinforcement learning works on a reward-penalty system, where the agent learns to maximize cumulative rewards over time. The key components include the agent, environment, state, action, and reward. The agent is the decision maker, like an AI system trying to solve a problem. The environment is the context in which the agent operates. Think of it as the playing field. The state represents the current situation, while actions are the possible moves the agent can make. The reward is the critical feedback mechanism that guides the agent, telling it whether its actions were good or bad. Imagine a robot learning to navigate a maze. It observes its current position, its state, chooses a direction, its action, receives points for reaching the goal or penalties for hitting walls, its reward, all within the maze environment, the environment. Applications of reinforcement learning include optimizing system configurations, adaptive resource allocation in cloud environments, automated testing and bug finding in software. To wrap up, let's talk challenges. Some challenges include defining appropriate reward functions, balancing exploration and exploitation, or dealing with large state and action spaces. Last, reinforcement learning often requires significant computational resources and time to train effectively. Be patient. Let's conclude this brief exploration in the world of machine learning. ML is revolutionizing the software and IT landscape. From supervised learning's predictive power to unsupervised learning's pattern discovery and reinforcement learning's decision-making capabilities, each approach offers unique tools for innovation. As software engineers and IT professionals, embracing these technologies is no longer optional, it's essential. The future belongs to those who can effectively integrate ML into their workflows, enhancing efficiency, uncovering insights, and solving complex problems. Remember, the field is rapidly evolving. So, it's critical to stay curious, keep learning, and don't be afraid to experiment. Start small and gradually expand your ML toolkit. By doing so, you'll not only future-proof your career but also be at the forefront of driving technological advancements in your organization. Thank you for watching and see you very soon for another AI tutorial. Okay, you're still here. I guess you can subscribe to my channel for more insights and be notified when the next tutorial is published. Thank you, again. Okay, seriously, you don't have to stick around. Today's tutorial is over. Alright then, stick around if you wish, but I'm leaving. Okay, I'm leaving now, see you.